Okay, so here we've got a little trebuchet problem. So what we've got is we need our trebuchet set up. Trebuchet set up. That's pretty hard to say. Trebuchet set up so that we are at least 230 meters away from Dorchtum's archers. But we also have to clear this wall that is 40 meters high. Okay? And so we don't know what the initial velocity has to be for our cannon. Okay? But what we do know is that our cannon is going to launch at an angle of 45 degrees. So we know that we're launching like this. And we know that this angle is 45 degrees. Okay, so we know that our projectile just clears this, and so it actually lands further in the city than this wall, okay? So this isn't our total range, okay? But this is part of our range. So we do, in a sense, know, because we know that our cannon is going to take I say cannon, it's probably a severed head or something. We do know that it's going to take a parabolic path. Now, it's a very crappy looking parabolic path, but we do know a point on this parabolic path right here. In a sense, we know that our x is 230 and our y needs to be 40 meters. So we can use this x, or dx, equals vx times time. Now, we don't know the time, and we also don't know this initial velocity. So since we don't know initial velocity, we can't figure out what Vx is. But we do know how to find Vx. And that is V naught cosine of theta. Well, in this case, that's 45 degrees. So what I can do is I can plug that in for Vx and plug this in for my distance. So I get 230 equals V naught cosine of 45 degrees. And all of that multiplied by time. Okay, that's going to be our first equation. We're going to come back to that in just a second. Now, let's look at this y. This height, or 40 meters, is our delta y from this point. Okay, so if we go up, our delta y has got to be at least 40 meters because we start at the ground. So delta y is going to equal positive 40. And we all know the equation for delta y. That's our bread and butter right there. V naught y t and then plus 1/2 a t squared. Now, we don't know V naught y, or our initial y velocity, because we don't know our initial velocity. But we do know that V naught y, or voy, is V naught. To find y, we use sine of 45 degrees. Sine. You can put the freaking, there we go. So let's take this and plug it in for V naught y. So take our delta y and plug it in. So we have 40 equals my V naught y over here, so V naught sine of 45, and all of that times time. And let's go plus 1/2 a t squared. So this is our second equation. So if you look at this, those of you that are ACT pros, we've got two equations, and if we look, we've got 1, 2 unknowns. So what I would do is I would solve equation 1 for time. Okay? So to do that, I just divide both sides by V naught cosine 45. So if I bring this down, excuse me, V naught y, I get time equals. Okay, cosine of 45 is just a number. So what if I go 230 divided by cosine of 45? Well, that gives me 325.26. Let's go 325.27. So time equals 325.27 all over V naught, because I divided both sides. So time equals that. So now take this. This is what time is. So take this and plug it in to equation 2. So we get 40 equals V naught sine 45. But instead of times time, now we've got times 325.27 all over V naught. And then plus 1/2. A, well, A in this case, we're assuming our trebuchet is on Earth, so A is going to be negative 9.8. Now, T squared is going to be this squared. So I'm going to put everything inside parentheses, 325.27 all over V naught, and I'm going to square that whole thing. So look over here. Beautiful thing. So 40 equals, let's simplify this a little bit. Go 325.27 times sine of 45. Oh, and look at that. We get 230. That's beautiful. So 230. Now plus, we've got to square this whole parenthesis. So I'm going to go ahead and do 1/2 times negative 9.8. I'm going to get negative 4.9. And then that times 325.27 squared is going to be a big old number. Let's see, 325.27 squared is going to be 105, let's go, 105.8, and then double 0. That'll be enough sig figs for us. And then over, I got to square the V naught as well, so it's V naught squared. So now I can subtract 230 from both sides. So 40 minus 230 is going to give me negative 190. Now, if I multiply over here, I've got a fraction, so I'm just going to multiply by the top. So 105,800 times negative 4.9, that gives me negative 518,420. And then very crucial, all over V naught squared. So I've got the V naught on the bottom. What I can do is I can cross multiply, because 190 is really over 1. So that becomes negative 190 V naught squared equals negative 518,420. So divide both sides by negative 190. You would get V naught equal to, let's see, we've got 2,728. Then, and that's V naught squared. So square root both sides. And we get, la 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 la, woo! That trebuchet is rocking and rolling. Let's go with 52 meters per second. That's a little bit more kick than the Nerf guns you used. So, in this case, this would be part A, the initial speed. And so the next part, I believe, is to find the total time it takes to get to the wall. Well, all you do now is plug in 52 into V naught, so you get 325.27 divided by 52, and you get a total time of 6.2 seconds. Now, the next part, now that you know what your initial velocity is, you can find your initial Vx and Vy components. Once you know Vx, you can figure out, okay, total time it takes, total hang time, because since you're launching from the ground, you know that delta y is 0. So let's go ahead and find out how far our trebuchet penetrates. So, if our V naught is 52, that means that our Vx is going to be 52 cosine of 45, which is going to be 36.77 meters per second. So dx equals Vx t. I know Vx, I'm looking for a total distance, but I don't know time. Well, to get time, you're going to use the fact that your trebuchet starts on the ground and ends on the ground, so delta y is 0. Well, delta y equals our v naught y t plus 1/2 a t squared. Now, v naught y is v naught sine of 45. And that comes out to be, oh, what do you know, 36.77. So, you would plug in 0 for v naught y, 0. Plug in 36.77 for time, or for v naught y, and you're going to solve for time. This will be the total hang time of your projectile. So to solve this, we do what we always do, divide both sides by t, and I'm going to go ahead and subtract 36.77 to the other side. It is without its t because I've divided both sides by t. That equals negative 4.9 t, and so total hang time is going to be 7.5 seconds. Now that you know the total hang time, plug that in and find your total distance. Now the last part, you need to find the speed with which it clears the wall. Well, at that point, you're going to need to know what your velocity components are in order to find out what your initial velocity, or what your speed is. Because the cannon is going to be coming down like this, and you're going to have a Vx, or you're going to have a Vy, and you're going to have a Vx. Well, we know what our Vx is. Our Vx isn't going to change. It's going to be 36.77. Okay? Now, what you can use is the fact that you need v naught y. Once you have v naught y, you can plug that in and solve for v naught. Okay? So, how to find our Vy at this time? Well, I know what time is. I know we figured out what time we got to the wall. That was up here, and it was 6.2 seconds. So 6.2 seconds to get to the wall. And I know that my delta y at the wall is 40. So if you know delta y and you know time, you can solve for your Vy at that time when it's clearing the wall. If you know Vx and you know Vy, you can solve for V naught because you have two sides of the triangle. And that, my friends, is trebuchet's keister style. Uncool keister style.